Hey guys, welcome to Vodcast 1.5. We're here to talk a little bit about pedigrees in genetics and also how it relates to our fruit fly experiment that we are doing in class. So let's get started. I'll make this pretty quick for you. All right, we call pedigrees also family trees. You've probably heard that used time and time again. Yes, pedigree is also a dog food, and it gets its name. The idea is that you're talking about the pedigree or the bloodline or the history of a family of dogs. Or animals and how great they were previously. So obviously the children have to be great because the adults were great. That's why they came up with the name, just in case you're curious. Side fact of the day. All right, let's get started. First off, basically what it is a chart to show you how traits are passed down through a family. And notice this weird, crazy looking thing here shows you basically some things are shaded, some things aren't. And we're going to talk about why some things are shaded and why some things are not shaded. It's also considered like an upside down family tree. So if you notice, up here is actually the oldest generation and down here is the youngest. All right, so how's this thing built? What was that whole crazy thing about earlier? Let's start off with the basics. Genders first. So males are represented by squares, females are represented by circles. Whether it's the mother or the sister, we use a circle. Doesn't matter. Okay, the basic rules are this. If you put a line connecting the two this way, horizontally, you're saying that they're married or that they're at least having kids. If you put lines going up and down, you are saying that they are the siblings. All right, so all of these pictured in this bottom one are all brothers and sisters. As far as the shading goes, if you don't shade it, that means it doesn't have the trait you're trying to track. If you have it half shaded, that means it shows a trait, but it carries another trait. If you fully shade it in, it has the trait. So what does this mean in practice? Think of this as the wild flies, okay? Has the trait for being red eyes. Think of this as the ones you got out of your F1 generation, all right? They all had red eyes, but they're carrying the traits, the brown eyes. And then this would be the ones that would be the brown-eyed flies, signifying that they obviously don't have the red. So here's a pedigree, what it looks like in general practice. You've got parent generation, they have kids. Those kids get married, and they have other kids. So you've got 1, 2, 3 generations in the pedigree. So if you were to build one for a fruit fly experiment, what would it look like? Well, we all start off with female and male flies. And I'm going to go back here and build a couple things. So first off, those flies reproduced, so I connect them with a horizontal line. They had kids. And no, I'm not drawing out some people's vials that had 250 kids because this would look like a disaster. So we're just going to draw in 4 kids for simplicity's sake. All right, and let's just say they had a couple of kids here. All right, so what do I have drawn up here so far to this point? Let's title a couple things. First off, this is my P1, and I'm going to set up another one, and this is going to become my F1. All right, so P1 generation, F1. So your original parents, one of which had wild eyes. So let's fill that in. So one had wild eyes, one did not. They had kids. Now, you notice from your experiment, something kind of weird happened. All of the kids had red eyes. Now, what you also noticed though, and maybe you did, maybe didn't, if these kids have half their parents' genetics, half of mom's and half of dad's, mom gave them the red eye trait. So they all had red eyes, but they're also carrying dad's trait for being sepia eyes, which means they express one gene but carry both. Kind of a weird concept to get a hold of. So again, they're carrying the sepia eye trait, but they don't show it. They show the wild eye trait instead, signified by the shading. Now, as we well know, we took the children from the F1 generation and crossed them, and they are producing what we have to look at yet in a couple of days, which will eventually be the F2 generation. So let's just say, out of all this, they have a couple of kids, know why it's doing that. There we go. What we're trying to figure out is, what are these guys going to look like? Are they going to be red-eyed? Are they going to be brown-eyed? Are they going to be a mix? Are they going to be a blend of red and brown? So that's what your F1 prediction should be. So when your F1 vials finally start to hatch, which they will in the next couple days, we'll actually be able to predict that. But the idea is that by looking at this, I can actually trace a trait down through family, see how a trait can get passed down. You could even try this in your families at home. If you look at who has what color eyes, you'll actually be able to see possibly where you got your eye color from. Maybe it wasn't your mom or your dad. Maybe it was your grandfather or your great-grandfather. Some of you may express traits that have been passed down throughout your family for decades, possibly from, say, 6-7 generations ago. People who you don't even have pictures from. So it kind of gets hard to trace traits back so far because really modern technology hasn't allowed us to capture these details until pretty recently, once color photographs were invented, which really wasn't too long ago. So a lot of the photos you may have from your grandparents are actually black and white, which unless somebody knew what color eyes they had, it's kind of hard to find that information out. But anyway, gives you a quick glimpse of pedigrees. Hopefully that helped you guys out at least a little bit. And have a good night.